Today we're looking at absolute value inequalities. So how we're gonna find the answers and solutions to this is a little different. In algebra, what you normally do is you normally get the solution by doing the algebra, then graphing it. We're gonna do it in reverse today. We're gonna graph it, then we're gonna verify that graph and solution using algebra. So let's look at number 1. X minus 4 is less than 9. Absolute value of x minus 4 is less than 9. Now what you see in the right here is completely analogous. Less than or equal to, greater than or equal to. Differences, we're going to include this. We're going to include the point. Okay, so remember what I said? We're going to graph it first, and we're going to use the algebra to verify the graph and the solution. So directly from the definition, if this is 4 on the number line, here's your 9 plus 4, or 4 plus 9, gives you 13. So this length is 9. This length is 9. And what we have here is 4 minus 9 gives you negative 5 here. So what this says is the absolute value of x minus 4 is less than 9. The distance from x to 4 is less than 9. So if I pick x here, that distance, and I'll write it this way, absolute value of x minus 4, that distance is less than 9 units. Likewise, if we pick an x in here, that distance from x here, so I'm going to even draw the x minus 4, that distance is always less than 9. So your solution set to this inequality, I'm going to push this up here, directly from the graph, is all points between negative 5 and 13. So that means every single point in this inequality satisfies that absolute value inequality. The algebra way you thought you did it, you were taught negative 9 less than x minus 4 less than 9. Okay? They said to put in this form first and solve for x. 4, 4, 4. Okay? And what we end up with here is negative 5 less than x less than 13. And notice that this is the same as that one. Okay? So we graphed the solution set based on the description and the definition of the absolute value. Use the algebra to verify your solution set. Okay, so let's look at number 2. I'm gonna move this up this way so you can see here. And number 2 is absolute value of x plus 2 is greater than 6. Okay. Again, we're gonna do the graph first, then we're gonna do the algebra. Okay. X minus negative 2, absolute value of x absolute value of x plus 2 is greater than 6. So let's look at by definition what we're looking at here. Here's a number line. Okay. Now we're saying that any value of x has any value of x to the number negative 2, that distance is greater than 6. So we're gonna pick the 6 here. So this is going to be negative 2 plus 6. That's 4. And we're going to pick the 6 here again. So this is 6. This is 6. This is negative 2 minus 6. Gives you negative 8. And this is 4. Okay? So this is your 6, the distance. Now, where would your x value have to be to get the distance from x to negative 2 bigger than this length 6? It has to fall outside of here. So if x goes in here, okay, so we picked an x value here. This is your x, absolute value of x minus negative 2. Notice this length is bigger than 6, and if we pick an x outside of here, this distance, x minus negative 2, okay, is greater than 6. So your solution set has to fall this way. So all values of x less than negative 8 and all values of x greater than 4. X less than negative 8 or x greater than 4. All these values will satisfy the absolute value of inequality. Okay, let's do it the algebra way. They tell you to do it. So x plus 2 less than negative 6 or x plus 2 greater than 6. You subtract 2 here, you get x less than negative 8, or subtract 2 here, x greater than 4. X less than negative 8 or x greater than 4. And there you have it. So it's probably easier to graph the solution set by the description of absolute value. Absolute value is always distance. The distance from x to a number, describing it that way, then verifying it with the algebra.